You can imagine a curve as a wire. It's technically it's infinitely thin wire, and it can be as long as you want it to be. It can follow any path that you want it to follow in 3D space, or however many dimensions your space has. Sometimes when people, a lot of times when they're talking about two-dimensional curves that go through a two-dimensional space, sometimes they'll define it like f of x, and f is actually the y-coordinate, and it's the function f. So it's a function of x. That will describe some curves, but only if they can be expressed as a function of x. So if you have something like a circle, it's not really going to work, because at a particular x value, you've got to have, the top and the bottom, so you can't really represent that as a function. But you can, so what you can use to express any curve that you want is the parametric representation. So this is about parametric curves. And the way it works is you have a vector valued function. So the output of the function is a vector. The input of the function is just a number, just a scalar. I'm going to call that S, the input S, and I'll call the vector valued function f. There's a curve drawn in the figure, and I've got values for s, some example values for s, 0, 1, 2, 3, 4, and so at each one of these values there's this vector valued function that we were talking about, f. The vector that it gives you is a vector that points to a point on the curve. So it tells you where that part of the curve is. So the part of the curve, there's one point on the curve that corresponds to s equals 0. There's one that corresponds to s equals 1, one that corresponds to s equals 2, s equals 3, and s equals 4. So in this case, if you started at 0 and I drew it as going up by units of 1, but you can the function f is defined for any number, any real number between 0 and 4. So 1.1, 1.2, everything is in there between 0 and 4. So you can just start at 0 and say what's the value of f at 0, and then go in small increments. Like if you wanted to do this, if you wanted to plot this on a computer or something, you could go in very small increments of like 0.01 and plug those numbers into this function f, and as you slowly went up and gave it these numbers, slowly increasing from 0 up to 4, it would give you the vector that you need to locate the point on the curve, and that's how you could trace out the curve. That's how the function f represents this curve. For the example, I said that s can go from 0 to 4. It can go from anything to anything. It could go from negative 1 million to positive 1 million. It's just that in this particular example, it goes from 0 to 4. And again, the nice thing about the parametric curve is that it could be any curve. It could be circles or spirals, and you can represent it. Whereas if you wanted to represent a curve and you said, well, I'm going to make it so that it's represented as let's say y as a function of x, then that can't represent any possible curve. It will only represent the kind of curves that have this property that basically they have one y value for each x value. I mean, if they don't satisfy that property, then you'll have a problem with that representation.